This is episode 2 in a series chronicling my adventures in building a DIY CNC router. If you missed episode 1, I'd suggest you go back and check it out. That way this video may make a bit more sense. Well, nothing more to say, but let's give it a try. With the cutting of the steel complete, the next step is to prepare the frame pieces for assembly. A quick look at the PrintNC Wiki tells me I'll need the number 1 X-frame drill guide in order to locate the 10 6.5mm holes in each side of the X-frame tubes. I always use the Fusion model as the final reference to verify the accuracy of the wiki. I choose the correct file from the drill guide export procedure that I did in episode 1 and print the guide. I highly recommend using a transfer punch for every hole-making procedure in this build. It just supplies that extra bit of accuracy when locating these holes. I found that a 7/64 or 2.7mm transfer punch fits the holes in this template perfectly. I reinforced the punch mark with a larger center punch. After going to all this effort to be precise, I don't want the bit to wander while drilling. As usual, I'll leave links to all the tools you see me using in the description below. Over at the drill press, I start out with a 4mm pilot bit and drilled all 60 holes. The green stuff is Anchor Lube metalworking compound. It's a water-based lubricant for drilling, tapping, and sawing, and I just love it. It cleans up easily with no oily residue and really makes a difference when performing cutting operations on metal. I'm not in any way sponsored by Anchor Lube, although if they wanted to sponsor me, I wouldn't say no. I just love the product. I changed out the bit to the recommended 6.5mm and completed all 60 holes for a total of 120 operations. Sure wish I had some automation like a CNC machine. Back to the wiki for step 2 instructions consisting of drilling and tapping and matching holes in the Y-frame tubes. You'll need the number 2 Y-frame drill guide, a 5mm drill bit, and a 6mm tap. I start by scribing a line 50mm off one end of the Y-frame tubes. I then line up the back end of the number 2 drill guide with the line and transfer all the locations. After reinforcing the transfer marks with a larger center punch, I do a quick sanity check to ensure the markings on the two tubes are symmetrical. Attention to detail here will pay off dividends at assembly time. I went back to the Fusion model to verify the measurements for the set of holes at the center. Using the center of the 5 holes, I got a measurement of 437.5 millimeters. I put down some layout fluid to better see the markings and used the drill guide's V-notch to mark the center of the tubes. I then marked the center hole on one of the tubes. I tried to get the 2 Y-frame tubes as close to the same length as possible, but to rule out any discrepancies, I used the initial 50mm mark at the tube ends as a reference point, tapping lightly until the marks lined up exactly across the square. I then scribed the center line on both tubes based off the initial 437.5mm measurement. This way, even if the Y tube lengths are slightly mismatched, I know the center X tube will be equidistant from the first X tube, and hopefully exactly parallel. Here we can see when measured from the end of the tube, the second center line came in at 438.5 millimeters, so the 2 Y-frame tubes are about 1 millimeter off in length. But again, because this line was scribed based on the 50mm line, the actual distance on both tubes will be exact. Whew! Okay, with that all marked, I lined up the center hole of the drill guide, transfer punched the holes, and reinforced them. The fact that one of these tubes was about 1 millimeter longer than the other really started to bug me, so I went back to the disc sander and cleaned up the longer tube until both matched exactly. With that adjustment done, I marked the final measurement of 786.5 millimeters directly from the far end of both tubes, punched in the marks, and called it good. Back over to the drill press to drill all the holes. First a 3mm, then 5mm, 60 operations total. Tedious. As a sanity check, I arranged the tubes upside down on the table and lined up the holes roughly with some drivers just to see if things were in the ballpark. Some cross-measuring and eyeballing convinced me that things were on track, but the real test will come when threading the fasteners. I used a file to knock down any burrs inside the X-frame tubes, as the fasteners will need to seat on this surface. A while ago I made a tool tryout video for an electric tapping machine. I'll leave a link to that video here. This project is why I got that machine. Tapping 30 M6 holes takes less than 10 minutes, and a third of that time is adjusting and clamping the workpiece. Now, I know if you hand tap holes for a living, you could probably thread 30 holes with a T-handle in 4.5 minutes. But for those of us who don't tap holes every day, this thing is amazing. The threads are consistently straight, well-formed, and best of all, no broken taps. This project requires tapping well over 100 holes, so in my mind, this tool is worth every penny. With the holes all drilled and tapped, it's time to see if this thing will go together square and true. Again, for ease of assembly, I'm doing this upside down to make initial fitting easier. Because this is a DIY project, it states very clearly in the wiki, as well as in the Discord forums, that steps can be taken if the holes do not line up exactly and not to panic. I tried so hard to make everything exact, but when dealing with clearances on threaded holes in steel, a 0.5 millimeter can be the difference between the fastener threading and not threading. In order to deal with that, the 6.5 millimeter holes can be enlarged a bit to create some clearance or wiggle room. It became clear that each of these tubes would be a custom fit, so using some blue painter's tape, I marked and labeled each tube so the order could be maintained. I was pretty obsessed with the idea of getting this thing parallel and square. I installed the initial center screw in each tube, then worked around the assembly to get all the screws in. If I came across a misalignment, I marked the hole and moved on. After getting all the screws in that I could, I removed all the screws and drilled out the marked trouble spots to 7 millimeters. If the screws fit after the modification, I moved on. If not, I went a little larger. 7.5 millimeters is about the extent of how large I could go. Anything larger and I'd need to use washers, not to mention the damage to my fragile pride. Assembling, disassembling, drilling, fitting, and on, the screws all started to fit one by one. When that last screw fit successfully, well, I was quite happy. With all the fasteners just snugged up, I removed the plywood and flipped the assembly over, which is easier said than done. This got quite heavy, quite fast. I used a combination of measuring across the diagonal both ways to check for square, as well as across the Y-beams for parallel. If things were not lining up, a few persuasive taps with a dead blow hammer helped provide the necessary corrections. I performed at least 123 more measurements to verify the frame was straight, parallel, perpendicular, plumb, square, and any other correctness checks I could think of until I somewhat satisfied my OCD. Once everything was in line, I went around and tightened everything down to lock the frame in place. All in all, I had to enlarge 5 of the 30 holes to get a proper fit. That was a fun but exhausting day. Well, it took a lot of fiddling, but the frame appears to be square and parallel. Please leave a comment. Let me know your thoughts on this project. Strike a like and subscribe to the channel if you're so inclined so you don't miss the next episode where we'll be dealing with linear rails and ball screws. Until then, I'm mainejason. Get out there and give it a try.